So, students, today we will start with the topic of chemical bonding known as dipole moment. Dipole moment. So, we should first know what exactly is dipole moment and how it is created. So, dipole moment is created in a particular bond or in a particular molecule due to the polar bonds, due to the polar covalent bonds. For example, let us take a bond which is found between A, B, in which the electronegativity of B is higher than the electronegativity of A. If electronegativity of B is higher compared to electronegativity of A, then what will B do? According to high electronegativity, B will pull the shared electron cloud towards itself more powerfully compared to A, which means the bond in which there are two electrons, B is going to pull these two electrons towards itself more powerfully compared to A. This is what the definition is. The definition of electronegativity is all about. So, if B is pulling electron cloud towards itself more powerfully, then there develops a partial negative charge on B, and there will be development of partial positive charge on A. So the first thing we should know how dipole moment is created is that it is created due to the polar covalent bonds. Okay, so dipole moment is created due to polar covalent bonds. Okay, and let us now know its value. The value of dipole moment is equal to the multiplication of the charges with the distance by which the different partial charges are separated, or simply the bond length, so its magnitude is equal to the charge multiplied by distance, bond length. Okay, so it is equal to the product of the charges developed and the bond length. Let us take this example again, in which we are having a bond between A and B atoms. Okay, in which the electronegativity of B is higher. So what will happen? There will be a development of delta negative charge on B, and there will be development of delta positive charge on A. Let us suppose the bond length between A and B is D. The bond length of the AB bond is E. So the magnitude of the dipole moment, which is represented by mu, okay, the representation of dipole moment is done by mu, is equal to the multiplication of the charge and the bond length. Okay, so it is going to be equal to delta multiplied by the distance. Delta multiplied by the distance. This is what dipole moment is all about. Okay, now we should also know that dipole moment is a vector quantity. Dipole moment is a vector quantity, so we have to also represent its direction. So the direction of the dipole moment is from the atom which is having delta positive charge to the delta negative, to the atom which is having delta negative charge. So if we represent the direction of the dipole moment in this particular bond, in which A is having delta positive and B is having delta negative, then the direction of the dipole moment will be from A to B, and it will be represented in this way. It will be represented in this way. Okay, this is the representation of the dipole moment. Now let us see why dipole moment is calculated and what is the use of this dipole moment? Why we are studying dipole moment? Okay, so if we talk about the application, if we talk about the application of the dipole moment, the first application of the dipole moment is that it is used to find the percentage ionic character in a particular compound or in a particular bond. Okay, it is used to find the percentage ionic character. Okay, it is calculated with the formula percentage ionic character. Percentage ionic character is equal to the mu observed upon mu theoretical multiplied by 100. Okay, where mu observed is equal to the value that we have just wrote down here. Okay, so the dipole moment will be what this is going to be equal to the multiplication of delta with the d bond length. And how will the mu theoretical will be calculated? So now here what we will do, we will assume this particular bond to be completely ionic, or this particular molecule to be completely ionic. And if it is completely ionic, then what we will say, we will say that A is having plus charge. A is basically a cation in such a situation, and B will become an anion. So in order to calculate mu theoretical, we have to assume that AB is a ionic compound. Okay, in order to in order to find mu theoretical, we have to we have to assume AB to be ionic. Okay, and if AB is ionic, then A will be having plus charge and B will be having minus charge. So the value of mu observed, the value of the mu observed will become equal to E into D. The value of mu observed will become equal to E into D, where the value of E is the charge of the electron, where the E is equal to the charge of the electron, as they are having plus positive and negative charge here. In this way we can find the value of the percentage ionic character in a particular compound. Okay, the one thing that we should know, the unit of the dipole moment, the unit of dipole moment that is most commonly used is debye. Okay, and 1 debye is equals to 3.33 into 10 raised to power minus 30 coulomb meter. The value of 1 debye is equals to 3.33 into 10 raised power minus 30 coulomb meter. This was the first application of the dipole moment. If we uh, take the second application, then the second application, which is more important for us, is that it is used to find the polarity determination. It is used in the polarity determination. Okay, so what is the point about polarity in it? So if in a bond mu is equal to 0, if in a bond mu is equals to 0, then bond is non-polar. Of course it will be, because if there are no charges developed on the two atoms, which is only possible when the both atoms are same, then of course the bond is basically what? The bond is non-polar. Okay, the bond is going to be what? Non-polar. If mu is not equal to 0 in a bond, then we will say that bond is polar. Okay, bond is polar, as we've seen in the above example, in which we have taken example of A and B. Okay, if the bond would have been in between A and A, then there will be no polarity developed. Okay, as the both of the A are same, there will be having same electronegativity. So the value of delta will be equal to 0. So mu will be equal to 0. Of course, it will definitely imply that this bond is what? This bond is non-polar in nature. While in the case of AB, where there was some difference in the electronegativity, resulting in the difference in the pulling of the shared electron, resulting into the polar nature of this bond, mu is not equal to 0 in such type of bond. If it is applied on the complete molecule, if it is applied on a complete molecule, if for a molecule, if for a molecule mu is equal to 0, then we will say molecule is non-polar. Okay, we will say molecule is non-polar. If mu is not equal to 0, then we will say it is polar. Okay, if mu is not equal to 0, then we will say that the molecule that we are discussing is going to be what? Polar. So this was the basic idea that we should know about the dipole moment. It is very quite obvious, if there are more than one bond present in the molecule, then we have to calculate the net value of dipole moment through the vector addition. As we have already written that dipole moment is a vector quantity. Dipole moment is a vector quantity. It is having a particular direction. So if there will be more than one type of bonds having different angles in between them, then we have to definitely go with the vector sum. Then only we can find the molecule's nature, whether it is polar or it is non-polar. So okay, so it was all about the basic idea about the dipole moment. Thank you everyone.